In this video, we will finish our discussion on unit conversion and dimensional analysis. But let's introduce the concept of density first of all. We talked about the SI system and the base units. However, we also have measurements that we do that have units that are not SI base units, but they can be derived from these base units. So we can combine the base units to derive correct units for whatever quantities that we have. One of these that we're going to talk about is the density. The density is a ratio of the mass of an object to its volume. So little d is density, is equal to the mass of the object divided by its volume. D is density, m is mass, v is volume. The SI base units for the density would be kilogram per or divided by cubic meters. Now these are very, very large units. Kilogram is a large unit for mass, and cubic meter, which is almost a cubic yard, is very large. And we don't typically take the measurements that large in laboratories. In fact, we used to deal with milliliters, and now most laboratories have moved to microliters or nanoliters, so very, very small amounts, and milligrams or micrograms. Therefore, the SI base unit is very, very large, so it's not very convenient for us and not very practical. Most of the time, especially in this for this class, we're going to use either grams per centimeters cubed or grams per milliliter, which are equivalent. So 1 centimeter cubed is the same as 1 milliliter, and obviously grams is the same. So for most solids and liquids that we're going to deal with in class, these are the units of density that we're going to be using. Here's a sample problem that you can try. Ice cube floats in a glass of water because solid water is less dense than liquid water. Calculate the density of ice at 0 degrees. Given that we have an ice cube with a side, so on each side is 2 centimeters, so 2 by 2 by 2, and it has a mass of 7.36 grams. Now, here's the formula for density. You first have to calculate what the volume is. Since cube is a regular object, figure out what the volume of a cube is, right? Length times height times width, and since they're all the same, it's going to be the same. Then you have a mass of 7.36 grams, so go ahead and solve for density. Lastly, we're going to talk about dimensional analysis. Using conversion factors to convert from one unit to another is dimensional analysis. Say that 3 times. We use actually more than one conversion factor in many problems, and therefore we're going to have to become comfortable with doing dimensional analysis, multiple steps. For example, if we want to convert 12 inches to meters, we cannot go directly from inches to meters, but we can go from inches to centimeters because we know that conversion factor from the English to the metric system. And then we know how to convert from centimeters to meters because that's within the metric system when we have the conversion units for that. So here's how we would go about it. We would start with the amount that you are given in the problem, 12.00 inches. Pick the correct conversion factor that will cancel the inches. So multiply that by the fraction where the inches are at the bottom because I want them to cancel. And then the centimeters are at the top. 1 inch has 2.54 centimeters. My inches cancel, and then multiplying these two numbers will leave me with centimeters. Now you can break this up. You can have this step and this equals the answer, and then take that and use this conversion factor, the second conversion factor, to convert to meters. Or you can do it all in one step, however you are more comfortable. But now that my inches are canceled, I am left with centimeters. And I can't stop there because I want to convert it to meters. That's what the problem is asking me. Therefore, I need to use one more conversion factor, the centimeters to meters. Go back to the little table and figure out what conversion factor you need to use if you're going from centimeters to meters. So this is the one. So multiply again by 1 meter has 1 times 10 to the second centimeters. Centimeters at the bottom because I will have to cancel it again. Right, so centimeters cancels, leaving me with meters. So 12 times 2.54 divided by 1 times 10 to the second will give me 0.3048 meters. Note that these numbers here in the middle are considered exact numbers because they're conversion factors. They're not going to limit the significant digits of your answer, only the original number, because that's your measurement. These are conversion factors. This has 4 digits because that decimal point makes these zeros significant. So 4 digits here, 4 digits here. This is a sandwich zero, so it's significant. This is a leading zero, never significant. 1, 2, 3, 4. I have the correct number of significant digits in my answer. Here's a sample problem where you will have 2 steps. The FDA recommends dietary sodium intake be no more than 2,400 milligrams per day. What is this mass in pounds if 1 pound is 453.6 grams? However, I can't use this directly because my original number is in milligrams, not in grams. So you have 2 necessary conversions. You have the one that's given to you in the problem, the metric to English to metric conversion, 1 pound equals 453.6 grams, and also the metric to metric conversion. So 1 gram has 1,000 milligrams. Now, once again, start with this amount because that's the one that you want to change. Set up your first conversion factor to convert to grams, where you need to cancel the milligrams. Go back to the little table in the previous video and figure out which one you need to use, which form of the fraction. Then once you have converted to grams, you can go ahead and use this one. So set it up as a fraction where the grams will be at the bottom because you need to cancel the grams at the top, leaving you with pounds at the end. Give it a try. Here's another sample problem. This is a little more difficult, but I have faith that you can do it. An average adult has 5.2 liters of blood. What is the volume of this blood in cubic meters? Here's the conversion factors. You have 1 liter equals 1,000 cubic centimeters. Then 1 centimeter equals 1 times 10 to the minus 2 meters. So you convert the liters first to centimeters cubed and then use this conversion factor to convert to meters. Note that here you don't just have centimeters, you have centimeters cubed. Therefore, you have to use this conversion factor 3 times or raise this to the power of 3, a third. So 1 centimeters cubed is equal to 1 times 10 to the minus 2 in parentheses raised to the third meter cubed. So either way, when you convert from liters to centimeters cubed, that's the first step. Then you convert centimeters cubed to meter. You will need to use this conversion factor 3 times because The unit is centimeters cubed, and this is only for one of those centimeters. Centimeters cubed is centimeter times centimeters times centimeters. So you have to use that 3 times. Give it a try. It's okay if you don't get it the first time, but just patiently work through it and you will get there.